The last thing we're interested in for Chapter 4 is Section 4.5, where we're interested in solving graphing linear inequalities, graphing linear inequalities. In two variables. So this winds up being similar to linear equations. The idea now is that we're looking at things like 3x plus 2y is less than 6. And so we know what values of x and y will satisfy this. And so first off, we can just ask, how can you tell if a point satisfies this inequality? So we could ask, is 2 negative 4 a solution to this inequality? And to answer that question, all we have to do is plug it in. We notice if we take 3 times 2 plus 2 times negative 4, that's going to give us 6 plus negative 8, which is negative 2, and negative 2 is less than 6, and therefore the answer is yes. If we had said instead something like 4, 1, then we would have tried it. We get 3 times 4 plus 2 times 1 would be 12, plus 2 is 14, greater than 6, and so for that one, the answer would be no. And so in general, what we're going to play with is solving these using a graph. So looking at that 3x plus 2y less than 6 again, what we notice is, to solve it, we first graph the associated linear equation. In this case, that would be 3x plus 2y equals 6. So, graphing it, we would say 2y equals negative 3x plus 6. Divide both sides by 2. Y equals negative 3 halves x plus 3. And so that would graph as a y-intercept of 0, 3. And then we got a slope of negative 3 halves, so we go down 3 over 2. And so we get that line. We're going to be careful though, because we notice that any point on that line would give us 3x plus 2y equals 6. We want 3x plus 2y is less than 6, and so we instead look at that line, but we draw it as a dashed line. So we've got the same two intercepts, but now we're going to draw a dashed line to indicate that we're not allowed to use any points actually on that line. And then we notice that we pick a test value. We notice that if we tried testing 0, 0, 0, 0 is always convenient if it's available. We notice that 3 times 0 plus 2 times 0 is less than 6, and so we shade that side of the line. If, on the other hand, we had something like x minus 4y is greater than 8, we notice now we would look at negative 4y is greater than negative x plus 8. We would divide by negative 4. Y would be greater than 1/4 x minus 2. And so now we're looking at that line y equals 1/4 x minus 2. So we can go up 1 over 4, up 1 over 4, draw a dashed line because it is a strict inequality. And now if we test 0, 0, we wind up getting 0 minus 0 is less than 8. And so we notice that we shade the other side. If we're going to be paranoid, we could double check one of those points. We could try 0, negative 3. It's pretty clearly on the other side of the line. And we notice if we try taking 0 minus 4 times negative 3, that's 0 minus negative 12 equals 12, which is greater than 8. So that works. So the only slight difference, if we said something like 3x plus 5y is less than or equal to 30, is that now we're actually allowed to draw a solid line again. So now we can actually use the intercepts. We notice that if x is 0, we know that y has to be 6. If y is 0, x has to be 10. So we can plot the point 10, 0. We can plot the point 0, 6. It's less than or equal to, so we can use a solid line. And then again, we can pick that point 0, 0. If we try 0, 0, 0 plus 0 is less than 30, and so we can shade that side of the line. So the only place we have to be really careful about our test value is if we said something like x plus 2y is greater than 0, we notice now 0, 0 is going to be on our associated line. We notice we're looking at 2y equals negative x, so y equals negative 1/2 x. So we've got a y-intercept of 0, 0. We can go up 1, back 2, or down 1 over 2. You notice that we want it to be a dashed line. So you notice if we'll just make it a dashed line. And so now we have to try maybe 0, 1. So we still pick the easiest point available. And we notice if we try 0, 1, we're going to get 0 plus 2 times 1 equals 2 is greater than 0. And so we can shade that side of the line. That includes the point 0, 1. So solving these inequalities usually isn't too complicated. One little thing to watch out for is if you're given kind of simple things, you notice that if you just said x is less than 2, we notice that we're just looking at the line x equals 2 and shading the set of value points where x is less than 2. If we said y was greater than negative 4, similarly, in fact we'll say y is greater than or equal to negative 4, we just find the line y equals negative 4 Now because it's greater than or equal to, we can draw a solid line at y equals -4, and then we shade the side of the line greater than or equal to -4. So one last thing that's just a little bit more complicated is if we said something like y is less than or equal to 3 and x plus y is greater than 2, we notice that we have to make sure we satisfy both conditions. So fortunately they're relatively straightforward. We notice that we're looking at the line y is equal to 3, and we're looking at the line x plus y is greater than 2, so that's going to be the same thing as we look at y equals -x plus 2. So a y-intercept of 0, 2, and a slope of -1, down 1 over 1, down 1 over 1, up 1, back 1. And so we notice that because we have to satisfy both conditions, we notice that y has to be less than or equal to 3, we notice has to be things less than 3, and then we check that x plus y is greater than 2. We notice if we try 0, 0, 0 plus 0 is less than 2, and so we're going to be looking at this region trapped less than or equal to 3, and also greater than x plus y has to be greater than 2. So, and also we have to be careful that it's a greater than, so we're watching that this has to be a dashed line. And so we notice this swirly shaded region is our solution. I don't know if we'll get any exam questions like that or quiz questions, but it's worth being aware of those.